Hey, Logan. Glad you could make it back for another installment of Math from Your Couch. Today, what I'd like to do is wrap up that section on simplifying rational expressions. So what we're going to do is we're going to go into it talking about how to simplify when you have monomials and binomials. So the idea is that a monomial is only allowed to simplify with a monomial, and a binomial is only allowed to simplify with none other than a binomial. So it's always whatever the type you are, you can only simplify. Monomials will never simplify binomials, okay? All right, so the plan is to just go through 6 examples. Let's start with the first one. Number 1, you're always going to want to factor if you can factor. Now, the top is a monomial, and if you want to factor that out to 2 times 2 times t, you can. But at this point in time, I'm going to say you guys might be ready for an upgrade in your simplifying. So we can leave it as 4t to the power of 2 since it is just a monomial. Now on the bottom, you'll notice that you have 2t to the power of 2 plus 22t. I noticed that they both can be divided by 2. That means they have a common GCF, a greatest common factor, of 2t. So I'm going to write down 2t, and then I'm going to write down what's left. So 2t divides that, that would need to be a t. And I can double check it, because if I multiply 2t times t, that would give me 2t to the power of 2. Then plus, that would have to be 11. And I can double check that. Let me change these t's here, make it look a little bit more fancy so I don't confuse it with the plus sign. And then the 11, I can multiply 2t times 11, and that comes out to 22t. So this right here looks perfect for us. It's been factored. We can't factor it any further. The next thing you're going to want to do is you're going to want to try to simplify. Now, since the top has a monomial, that means no addition or subtraction. That means it can only cancel with another thing that has no addition or subtraction. So you'll notice in the parentheses here, the addition subtraction limits it, prohibits it from being canceled with the monomial on the top. The only 2 things they're going to be able to cancel are these 2 guys right here because they're both monomials. Now, when they cancel, the 2 and the 4 cancel, leaving us with 2 on the top. So I'm going to have a 2 on the top. Over, and then t plus 11 is going to have nothing to cancel with. I'll take care of that in a second, though. You'll notice that on the top I have 2 t's and I have 1 t. So I'm going to cancel this t with one of the t's here. Now notice when I said I canceled it with one of the t's, I just canceled out the 2. That way I can say, hey, instead of having 2 t's, t to the power of 2, I only have 1 t, t to the power of 1. So on the top I have 2 and t, right? Because when you canceled the 2 and the 4, you had a 2 left. And then we have t plus 11. So our final answer is 2t over t plus 11. Question number 2. All right, so we're going to go ahead and simplify. On the top, you'll notice that you have 3b plus 9. So over here, we have 3b plus 9. They can both be divided by 3, so I'm going to factor out the GCF of 3. And that's going to leave me with b plus 3. Now, if you don't believe that that's it, you can go ahead and FOIL, or distribute, 3 times b is 3b, 3 times 3 is 9, and it comes out to be the same exact thing. So you can always double check your math. If you redistribute, it should come out to the original polynomial. All right, over, and then we're going to factor the bottom denominator. The bottom, they both have an 8. They're both divisible by 8, so I'm going to take an 8 out. And then that would give me b plus 3. So now what we have is we have on the top a monomial and a binomial, and on the bottom a monomial and a binomial. Now remember, binomials can only cancel other binomials if they're exactly the same, kind of like those guys. Now 3 and 8 have no common factors, so my final answer here is going to be 3 over 8, or 3/8. Moving on to question number 3. Now number 3 is a little tricky. Anytime you're dealing with these types of problems, you're going to want to put it in order. And what I mean by that is you want to start with variables with the largest exponent. So on this one, the negative 2z, that actually should go in the front. So I'm going to rewrite it as negative 2z plus 5 over, and the bottom looks like it's written okay, so I'm going to just write 2z minus 5. Now, there's a trick with these types of problems. You'll notice that the 2z and the 5 on the top and the 2z on the 5 on the bottom are exactly opposite. What that means is you can factor, or you can write it as one of them, not both of them, but one of them with a negative 1 times, and then change the signs, 2z minus 5. And if you distribute this negative 1, just to double check, you'll notice that you'll get negative 2z, and you'll get a positive 5 back in the problem. Now, we don't want to distribute it. We just want to leave it factored like that, over. And since the denominator has nothing in common, I'm just going to write 2z minus 5. And you'll notice now that the denominator and the numerator have the same exact binomial factors. So we're left with -1 over 1, or just -1. All right, moving on to question number 4. Question 4. I just wanted to say, at any point in time, if this is going too fast, go ahead and slow it down. If something didn't make sense to you, rewind it, okay? So skip it back or skip it forward, and then you can find the problems you need. If this is going too slow, by all means, speed it up. All right, question number 4. 6a to the power of 2 plus 12a over 9a to the power of 3 plus 18a to the power of 2. So we're going to go ahead and factor this thing. What I mean by that is we're going to take out what they have in common. So I wrote the problem down so you could see it. This one's a little more intense. They both can be divided by 6. So I'm going to divide the top, right? I'm going to factor out a 6, but they also have an a. So I'm going to take out 6a. And then I need to figure out what goes inside the parentheses so that if I was to distribute, it would take me back here. Well, to multiply 6a times something to get 6a squared would need to be a. And then what do I need to multiply 6a by to get 12a? Well, that would need to be a 2. So I have 6a over a plus 2. The next thing I'm going to do is I'm going to factor the denominator, noticing that they can both be divided by 9. And they also have 2 a's in common, or an a to the power of 2. So that means their GCF is 9a to the power of 2. And then I just have to figure out what's going to go inside my parentheses so that it stays what it was beforehand. So I just need to make sure, yeah, it just needs to multiply by an a. So if you multiply 9a to the power of 2 times a, that gives you 9a cubed. And then I just need to multiply 9a squared by 2, it looks like. So I'm going to say plus 2 right there. And that way when I distribute, or if I was to distribute, it works out exactly as where it originally came from. All right, so now I take a look at the top and the bottom. Remember, monomials with monomials, binomials with binomials. The a plus 2's, those guys can cancel out. Now the 6a and the 9a squared. The 6 and the 9 can both be divided by 3. 3 goes into 6 2 times, and 3 goes into 9 3 times. Next, it looks like they have an a in common, so I'm going to take 1a from the top, and I'm going to take 1a from the bottom, and I just cancel out the exponent to show that there's no longer an exponent of 2, it's now an exponent of 1. And then on the top, you'll notice that all I have left is just the 2. So I'm going to write just the 2 on the top, over, and on the bottom I have a 3 and an a, so I'm going to write 3a. And here's our final answer for question number 4, 2 over 3a. All right, so let's take a look at the next example, problem number 5. So number 5, you'll notice that the order is incorrect, so I'm going to switch that guy up. So for number 5, let's switch up the order on the top. That's going to be negative y to the power of 2 plus 4 over y to the power of 2 minus 3y minus 10. Next, I don't like having a negative in the front of the y squared, so I'm going to factor out a -1. So I'm going to say -1 and then y to the power of 2 minus 4. It just changes the signs of the numbers inside the factor. Over y to the power of 2 minus 3y minus 10. Now, there's no GCF on the top. There's also no GCF on the bottom. I can't cancel out the y squares because those are parts of a binomial and part of a trinomial. You must cancel out binomials with binomials and trinomials with trinomials, not parts of them. But I can factor these polynomials. On the top, I can factor 4 to 2 and 2, and since there's no middle, I know it has to be a positive 2 and a negative 2. Now, since the y squared is there, I'm going to go, let's go back, sorry. Let's go with the -1. So we have the -1 in the front, and then we're going to have 2 parentheses. Over. All right, now since the y squared is there, we know that that's y times y. And then the 4, like I said earlier, the -4 is going to be positive 2 and negative 2. That way they can cancel out to make the 0 in the middle that you don't see. Next, y squared minus 3y minus 10. 10 is 5 and 2. Since the minus sign, I'm going to subtract the 5 and 2 to get 3, and that works out perfectly. So we're going to go y squared is y times y, so we need 2 binomials, both starting with a y. It needs to be -5 and positive 2 to get that -3, so I'm going to go -5, positive 2. And I notice I can cancel out the y plus 2's because they're the same exact factors. Now the y's I can't cancel, even though they're part of binomials. Like I said, the entire binomial must cancel and not just parts of it. So our final answer is going to be -1 times the quantity y minus 2 over, that's right, y minus 5. Now, if you want to remove the parentheses or distribute and keep the remove the parentheses through distributive property or keep the parentheses, that's your choice. Okay. All right, moving on to our last question, number 6. This guy looks a little intense. There's a lot of numbers and a lot of exponents going on here. So we're going to write it out. 3x to the power of 2 minus 12x over 6x to the power of 3 minus 24x to the power of 2 plus 24x. Now, I know they all can be divided by 3. That's not something I want to be thinking about. I want to focus on the top and the bottom. So I don't mean that they all, I don't want us to look at that, what they all have in common, all 5 terms. Let's just focus in on the top. So on the top, they both can be divided by 3. They also have an x in common. So I'm going to factor out the top with a 3x. That's the GCF. And then I'm going to write down the parentheses. Now, 3x times, I need another x, so 3x times x would give me that 3x squared, and 3x times negative 4 would give me that negative 12x that we've got in there, over. Now I'm going to go ahead and factor this guy here, noticing that they all can be divided by, all of them can be divided by 6, and they all have an x that's in common, so I'm going to take out a 6, and I'm going to take out an x, parentheses. That right there would need to be x to the power of 2, so I'm going to write in x to the power of 2. This right here, 6x times 4x, negative 4x. And then this last one would be 6x times positive 4. All right, so still not done. The bottom trinomial can still be factored, so I'm going to go ahead and factor that just a little bit more. So we have 3x over x minus 4. Now, if you notice that the 3x and the 6x can cancel, that might be a good idea to cancel at this point in time. I like to wait till the very end and do all my canceling all at once. Now, x squared minus 4x plus 4, the x squared is x times x, so I'm going to go with 2 parentheses, each parentheses having an x in the front, and then the 4 in the back is going to be 2 and 2, and since there's a positive 4, that means addition. So I need to add these numbers to get negative 4, which means they both need to be negative 2s. And then I notice that I can cancel here. These x's can cancel out. So they're going to cancel out completely. And then the 3 and the 6 have 3 in common. 3 goes into 3 just once, and 3 goes into 6 2 times. Now, I don't need to write the 1 on the top unless there's something there. So I'm just going to, unless there's nothing there, sorry. So I'm just going to write x minus 4 on the top. I like to keep the parentheses on the problem. And then 2 times, and then x minus 2, and x minus 2. Now, since the x minus 2 does not match the x minus 4 exactly the same, you can leave it just like this. Now, some people might want to touch up their answer and write x minus 4 over 2 times the quantity x minus 2 squared for some fancy points. But I'm going to be honest, either of these answers here are totally acceptable and exactly the same in my book. Okay? So you don't have to pick one. You just have to pick one or the other. All right. Go ahead and try the assignment. It's going to be a little tedious. It's a lot more work than normal. There's only 7 problems. Do the best you can. And if you have any questions, please don't hesitate to email me or contact me via Google Classroom. You can also show up for virtual tutoring or virtual office hours. I hope you have a great weekend, and I'll talk to you guys on Monday.